The lesson outcome for this video is, I can solve compound inequalities. So, a compound inequality is an inequality that contains two separate inequalities that are joined by a couple of different possible words. Those words are and or. Okay, so you might have one of them or the other, and we'll talk about the difference between them right now. So first of all, in the purple writing here, you see the graph of a compound inequality with the word and is the intersection of the graph of the inequalities. That's the word intersection there. This is when then both things would be true. So for example, x is greater than -2 and x is less than or equal to 3. So both of these inequality statements are going to be true when we look at the solution to this graph. All right, so just like we did in previous lessons on inequalities, we're going to start by doing some graphing. Now we need to plot both -2 and +3 on our number line. All right, so I'm going to say, all right, well, let's call this 0 right here. Then we've got 1, 2, 3, and we need to get to at least 3. And we've got 1, 2, 3 negative, so -1, -2, -3, and that will cover both of the values we need. So x has to be greater than -2. So the first thing I want you to remember is that we're going to put a circle at -2, but we're not going to shade it in because it's just greater than -2. Then we're going to go over here to 3. We're going to put a circle at 3. And then we realize we do shade that in, and we shade it in because it says that x is less than or equal to 3. So because it can be equal to 3, we shade that 3 circle in. Now, what it's saying again, remember, is that x is greater than -2. So if we think about, here's -2, numbers that are greater than -2 are this direction, right, on the number line, infinitely this direction. And then numbers that are less than or equal to 3, well, here's 3, equal to 3. Less than 3 would be this direction, infinitely this way. Now, it has to be true for both x is greater than -2 and x is less than or equal to 3. So if it has to be true for this and this, then the only place that that would work is actually in between those 2 points. So that is the solution. If you think about it for a minute, you can test a point. How about the point 1, +1? Here's +1. Is +1 greater than -2? Yes, it is. And is +1 less than or equal to 3? Yes, it's less than 3. So the number 1 should be shaded, and it is. But if we tested another point, let's say the point out here, like 4, is 4 greater than -2? Well, yes, it is. And is 4 also less than or equal to 3? Well, no, it is not. 4 is not less than or equal to 3. So it should not be shaded, and it is not, which is why we have this portion shaded. That is the intersection of our two inequalities. Now let's try the example here in the green. The graph of a compound inequality with the word or, with this word, or, is what we call the union of the graph of the inequalities. All right, so we will take a look at this example. It says x is greater than or equal to 0, or x is less than -1. Okay, so that means either this is true or this is true. All right, so we're going to go ahead on our number line again, and we're going to, I'm going to start with 0, and then go 1, 2, 3 to the right, and I'm going to go 1, 2, 3 negative to the left. All right, so x is greater than or equal to 0. We're going to put our circle at 0 here. It does say x is greater than or equal to 0, so it can be equal to. So we're going to shade that circle in because it can be equal to 0. Or x is less than -1. Or is less, x is less than -1. So here's -1 right there. Now we don't shade that in because it doesn't say less than or equal to. And then, so yeah, now we have to decide where to do our shading. All right, so again, or x is greater than or equal to 0. Where's greater than or equal to 0? Well, here's equal to 0, and greater than 0 is this direction. But then where is x is less than -1? Well, here's -1, it's less than -1, and where's less than? That's this direction. So because we're saying it's got to be one or the other, we're going to shade this direction, because x has to be either greater than or equal to 0, or it has to be less than -1. So we also shade that way. Now if you think about this for a minute, the only space that is not shaded on this whole number line is right in here. Any space between 0 and -1, and of course the -1 itself. So if we thought about the number right in here, -0.5, would that be shaded? Well, it shouldn't be because, well, it's not shaded on this graph. So let's think about it for a minute. Is -0.5, -0.5, greater than 0? Well, no, because it's a negative number. Or is our x value, which we're just checking, -1/2, is -1/2 less than -1? Well, no, -1 is less than -1/2 because it is more negative. So that point there should not be shaded in, and it's not. So it makes sense. If we checked again the number 1 in both inequalities, is 1 greater than or equal to 0? Yes, it is. Or is 1 less than -1? And no, it's not, but it is true for 1, just not the other. But since it's or, it doesn't matter. All right, let's try some examples. Translate the verbal phrase into an inequality. Graph the inequality. So number 1 says all real numbers that are greater than or equal to -4 and less than 4. So first of all, notice that it says all real numbers. We're looking to graph all real numbers that are greater than or equal to -4 and less than 4. What we use to represent all real numbers is x. And again, we're graphing on a number line which contains the real numbers, a real number line. All right, so all real numbers, we'll call that x, right, that are greater than or equal to, -4, and the next part says less than 4. All right, so we're going to say and x has to be less than 4. So I know it just says here less than 4. It doesn't say all real numbers again, but that's what this phrase is saying, and we can walk through it again one time right now. So all real numbers x that are greater than or equal to -4. So x is greater than or equal to -4. And the x values, again, the all real numbers, x when it's less than 4. Okay, so we need to find numbers that are true for this inequality and this inequality. We're finding their intersection. All right, so since I know I need to go all the way up to 4 in the positive direction, and we have to go to -4 towards the left. There we go. All right, and so we're going to graph these individually and then try to find out where both are true, because again it says and. So x is greater than or equal to -4. Here's -4. It's greater than or equal to. Because it's or equal to, just like we talked about in previous lessons, that's going to be filled in. And x has to be less than 4, so we're going to go ahead and fill in the circle, or not fill in the circle, or put the circle at 4 but not filled in, because x is less than 4. And now we're going to talk about where are their values that is true for x is greater than or equal to -4. So here's -4. Where is it greater? Well, it's greater this direction. And where it's also true that x is less than 4. Here's 4. Less than 4 will be this direction. These are all numbers that are less than 4. And we need both this and this to be true for x. So our solution is in between our 2 points. Again, we could test this out by choosing a point like over on this side of the number line, like -5, or we could test the number in the middle like 0, and we could test a number over here like +5, and make sure that the shading is correct for each. Really quickly, so if I use -5, is x greater than or equal to -5? No. So it can't be true for this and this if it's not even true for this. So this shouldn't be shaded. And it's not. Then 0, is 0 greater than or equal to -4? Yep, 0 is greater than -4. And is 0 also less than 4? Yes, it is. So this should be shaded because it's true for this and this. And the last one to test is 5. So is 5 greater than or equal to -4? It sure is. 5 is greater than -4. And is 5 also less than 4? No, it's not. Since it's not true for both, it shouldn't be shaded, and it is not. All right, the next example. Again, all real numbers, we'll use x there, all real numbers that are less than -1 or greater than 2. So I'm looking for numbers that are less than -1 or numbers that are greater than 2. All right, so we're going to go ahead and graph this example. Here's 0, -1, -2, +1, +2. Maybe we go beyond that. It doesn't really matter, and usually number lines will be provided for you. All right, so x is less than -1. Here's -1. X has to be less than -1, or x has to be greater than 2. So here's 2. Now, which one are we going to shade in of those 2 points? I hope you answered neither, because we don't have a less than or equal to or greater than or equal to. So they're both going to stay open. So x is less than -1. Where's the x less than -1? Well, x is less than -1 this direction. X is less than -1. And then we're going to look at the second part. Where is x greater than 2? Well, x is greater than 2 this direction because the number 3, for example, is greater than 2. So we would shade this direction. And if you think about it as a compound inequality again, we want to know what are the values of x that are both, or not both, but what are the values of x that are less than -1 or that are greater than 2? Well, these values and these values.